Now for this problem, we have an object that is being launched at an angle. So the ball comes off the bat at a velocity v equal to 45.7 meters per second at an angle of 40 degrees. It says that assuming that the ball is caught right here at the same height from which it is launched, figure out how far the ball has traveled horizontally. Okay? So just like every projectile motion problem, you need to list your givens in the x separate from the y. All right? Now the first thing I realize is that we have a velocity in two directions. We have an x component and we have a y component initially. Okay? We need to figure out what those two components are. So just down here in our given section, I'm going to write my x velocity is going to be equal to v times the cosine of theta. And we got that from our trig functions, that this is the adjacent side to the angle. This is the hypotenuse, so we use the cosine because it's adjacent over hypotenuse. A little manipulation and we get this. So we have to plug in 45.7 into v, because that's the hypotenuse, times the cosine of 40. And we should get a velocity of 35 meters per second. If you didn't get 35, go into your calculator, hit mode, scroll down, highlight degree, enter, exit out, try it again. For the y direction, and this is our initial y, that's our constant x, we're going to use the sine function, v sine of theta. And again, plug it into our calculator as 45.7 sine of 40, and we'll get a value of 29.4 meters per second. So those are the velocities that it is traveling in each direction immediately after impact. All right. This is the most challenging part. This is what most people forget to do. Now we just have to figure out what else we're given. Well, it asks us to figure out how far it travels in the x, so I know that that's what I'm looking for. And I only have one more option in the x, and that's time. It does not tell us time. So this is a common type of problem where they ask you to solve for something in one direction, but you have to find time in the other direction first. So we know in the y direction we're going to have to find that time. It's still free fall, so gravity is negative 9.8 meters per second squared, and we have a couple options now. Our job is to find the time it takes to go from here to here, so the total time. A couple different ways you can do that. You can go from beginning to the highest point, use that max height, and multiply it by 2, or you can figure out the entire time directly. I'm going to figure out the total time directly. There's two things I can do. I can use that the delta y is equal to 0, because this starts at a height of 0 and ends at a height of 0, so there's no change in height between the beginning and end points. The other thing I can do is use that the final y velocity is going to be equal and opposite to the initial y velocity. Okay. Either way, you're going to get the correct answer. I think I'm going to make my life easy, and I'm going to use that the final y is equal and opposite. It gives me this equation. If I manipulate it for t, I have v minus v naught divided by a is equal to t. All right, so we have negative 29.4 meters per second minus positive 29.4 meters per second, all divided by a negative 9.8 meters per second squared. You can see that negative down here is important. Can't forget that. So if we do this minus this, we get negative 58.8. Divide that by the negative 9.8, and we'll get a time that is positive, 6 seconds. If you ever end up with a negative time from your equation, you know you did something incorrect. So now that we have that time is 6 here, you plug it into the x direction. X is equal to velocity times time. 35 times 6 gives us a velocity, x distance traveled of 210 meters. All right. So, still a relatively simple type of problem, a lot of work. This is the most commonly missed part of the problem.